record every time. So yeah, our goals are to define the term operating system, look again at what an interface is, examine the various roles that an operating system fills on a computer system, look at some of the key components that make up one, and list a few examples, mobile and desktop operating systems. And I think we can think of a few off the top of our head. There we go. So first and foremost, an operating system is a computer program. It's like any computer program in that it just runs on a computer. It comes like preloaded with a bunch of apps like a file manager, usually a settings applet that lets you change basic settings, change the desktop background, all that stuff. Those are all apps that are kind of built into it. It is a really big computer program though, like huge, millions of lines of code. Its first job when you first turn on a computer is to tell a computer how to be a computer. This is just inert metal, plastic, and silicone. And at the start, when you first turn it on, it doesn't know anything. It is incapable of performing any useful task. So the first thing that the operating system does is like start firing up all those circuits, explain the rules of the game, and kind of establish how a computer is going to behave and do this job. And in this way, it has three main jobs. A boss, it works as an assistant, it works as the referee. So as a boss, the operating system's job is to lay out the rules for all the other apps to obey. It kind of gives the whole operating system structure. It makes sure that everybody plays nice with each other, and it is the final authority on who gets access to what resources. It creates boundaries for all of those devices and software, and it's kind of an interesting fact that all apps need permission from the OS to do anything useful. It has to, if I want to write to the disk, I have to ask the operating system for permission to do that. And sometimes the operating system has to ask you, the user, for permission to do stuff like that. Sometimes it's all tacit though, like you load an operating system, or a word processor or something like that, it's going to be able to write to files because it's already been given permission. But the OS isn't just the boss, it's also the assistant. In order for an app to be useful, it has to be able to access resources on the system. A web browser needs to be able to access the network controller. Hi, Donna. The word processor needs to be able to access your hard drive. A video game needs to be able to access your graphics processor. You know, these things, the operating system's job is to make sure that all the apps that are running on your system get the resources that they need in order to work. Oh yeah, those were the same examples that I had before. Its other role is as kind of a referee. So if all these other apps, since multitasking is the most important thing that we can do, like a computer is useful, we kind of expect that we be able to run multiple apps at a time. I have 1, 2, 3, 4, 5, 6, 7, 8, 9 user-facing apps running right now on my computer, and I want them all to be able to play nice with each other. And it's interesting because only one of them can ever be doing anything at any given time. The CPU literally can only run one. What's the word? One command at a time. And so it's the operating system's job to kind of schedule everybody to you get a few milliseconds, you get a few milliseconds, you get a few milliseconds. And it's seriously down to millionths of a second or thousandths of a second. And they're constantly trading off who is able to access the computer. You never notice it. You don't see it. Everything just seems to be running at the same time. But they are all, like, each app is pausing for a second in its execution while another one does its own little routine maintenance or changes the slide on the slideshow or something like that. It is also the case that apps have a tendency to crash on occasion. right here. The operating system's job here is to make sure that when an app does something that messes it up, that it's going to crash, but do it gracefully. Like back in the day, if an app crashed, it could crash your whole system. Like everything would come tumbling down like a bunch of dominoes. Now, uh, it's become a really big deal for apps to be able to crash in a way that isn't going to corrupt data or bring the whole system down with it. So there's all these mechanisms built into the operating system that help it to uh, like kind of compartmentalize each individual app and give it its own little space. So if it crashes, it's going to just crash itself and not everybody else. And also kind of coupled with that is the fact that operating systems are really concerned with security. So this is kind of these two things are very closely related with each other, because we have viruses out there, we have malware, we have spyware, we have all sorts of nasty little pieces of software, people trying to steal your money and whatnot. And so as part of like preventing some app from crashing your whole computer, they're also trying to prevent them from doing other malicious things like encrypting your hard drive and asking for a ransom. Did you guys hear about that? The LLBO got a ransomware attack and lost a lot of data, like so many millions of dollars.
That's what I was sketched out about the website.
Well, that's yeah, yep. We have a self-signed certificate, is what that is. That's why that does that. It is encrypted, but it's encrypted. We didn't like buy a certificate from a third party. We made our own, and normally that's considered a no-no. But it's fine. It does work. It's just self-signed and not signed by some certificate authority. So the websites don't trust it, or the web browser doesn't trust it. So yeah, Windows, for example, has a whole security suite called Windows Defender, built right into the thing. Operating systems like Android and iOS have their security is a little different. First of all, the system is just really locked down to begin with. You can't actually install anything that's not on their app store. It won't let you. Unless you change some settings in the developer menu, and you like if you want to sideload some app from some other sketchy website, you have to like A, know how to do it, and B, like be willing to like void your phone's warranty and stuff like that. So if you're an app developer, you've got to do this. So there's a few different components. I'm going to go over these very briefly because we don't need to know these in any super detail. My goal here is just to kind of give you like a high level look at all this stuff, just to build general awareness. It's not really, the goal here is not to make everybody experts on all the components of an OS, because again, this is an apps class. What we're really doing is trying to get up to the point where we're going to start working with our the software, like word processors and stuff. So the OS has what's called a kernel, which is a part of the operating system which we don't get to interact with on any level whatsoever. We never touch it. And that's by design, because we wouldn't want to. Everything is very low level. It's the part of the operating system that manages your memory and your hard drive access, your network controller, and all that stuff. It's like really, really low level stuff. And on top of the kernel is what's called an interface. Kind of like you have an interface where you can interact with a computer via a keyboard and a mouse and things like that. There's an interface between the kernel, the really low level part of the operating system, that programs can run on top of. The programs have to access this interface and say, hey, can I write to the hard drive right now? Or hey, can I send a request across the internet right now? I want to look at cat pictures and find videos of bunnies on YouTube or something. Whatever the app wants to do, it has to ask permission via this program execution interface. Next. Yeah, there's all of the different resources on the computer. There's a whole components that are devoted to making sure that every app has enough memory to run, every app has access to the screen if it needs it, can create all of its little buttons and other user-facing interface doodads, that's the word. They usually will have some sort of file system, so you can manage long-term storage. So I write a letter, I want to be able to save it somewhere, and I can't actually save it in the memory because the memory gets wiped every time you turn off the computer. So it has to be written to some other device, what we call a hard drive. And there's a whole system for doing this. There's all this really clever, creative stuff that's gone into creating a drive that you can permanently store information on, or for long term. It's nothing lasts forever. They're usually it's a disc. It's a shaped like a disc, and it's covered in like magnetic dust. And there's a tiny microscopic needle that reads those little magnets and their orientation. It's really complicated. I honestly don't really know how it works, except in a very basic way, because more a software guy than a hardware guy. There's you guys all have a computer that has a microphone, a camera, speakers, keyboards and mice. All of those devices have to have some sort of a contract with the system for how they're going to operate and how they're going to communicate with the rest of the system. So every computer has a system where you can store and install device drivers. Usually does it automatically. You can plug in any mouse on a Chromebook or a Windows or a Mac, and it'll just work. You don't have to worry about it. But that first time you plug it in, there's a contract that's established. And that contract is a little piece of computer code called a device driver. Every computer has some way of providing networking capabilities. It is not the case that any computer that's useful today does not have some way of networking with other computers. I might not have been confident saying that like 5 years ago, but I'm quite confident saying that now. Any useful computer is going to have some kind of networking capability at this point. Whether it's on all the time is definitely, a question. You can turn off your network, go into airplane mode or whatever, save battery. You can play games offline. You can do a lot of stuff offline that's just local to your computer, but sooner or later you're going to want to send that to somebody or do something online. Networking is fundamental to every system. And then most computers have some sort of security built in. Whether it's just really, really difficult to install something without the user's permission, or they have a security virus scanner suite built in like Windows does. And they'll also always have some sort of user interface. On Windows, let me just pause this here real quick, because on Windows that they use we call it a WIMP interface, which stands for Window Icon Menu Pointer. We have windows, so like here's my calendar for the week. It's full of orange. So this is a window. They can slide around each other. So here's a web browser. So I have two windows here, and if you look in the text, I actually show a couple of tricks and stuff, and I can show them to you now. I'm still showing my screen. So this desktop metaphor allows us to have multiple windows open and see how they can occlude each other. Like this one's on top of the other one, so they're like pieces of paper sliding around on a desktop. I know we don't usually think about like what this all means because we just get used to it, but this is really fundamental. This was like a huge breakthrough when they came up with this idea of the desktop. So window, icon, we have icons everywhere. There's a couple up here on the top left. There's a whole row of them on the bottom of my screen. Then menus, we have menus. Like here's a menu that allows me to see my schedule in different ways. Here's a menu that, this is where I can see all the different calendars that I've loaded in. I can see, yeah, well, here we go. Here's all my menus from my web browser here. And then Windows icon menu pointer. Yeah, something to interact with it all. On a touch screen, it's your finger. On this, I have a mouse, and I have a device that acts like a mouse, which is this tablet here and this stylus. So I can, scroll up and down on this thing and interact with the system in interesting and useful ways. So let's go back to this again. Swap, I don't know why it always does that. So some sort of user interface, some way for the user to interact with the computer in an intuitive way. And they're getting really good at making them as intuitive as possible, like to the point where we don't even think about things like files anymore. So here are our big examples. There are hundreds and hundreds of operating systems available on the market these days, but these are the biggest ones. These are the ones with the largest market share. For your workstation OS, you have, whoops, just every time I gotta swap these, you have Windows, Mac OS, Chrome OS, and Linux. That's it. Linux is kind of a misnomer because you wouldn't use Linux by itself. There's a whole bunch of other operating systems that go along with it, but I'm just gonna put them all in the same place. But Windows and Mac are probably the two biggest workstation OSs. Most companies use Windows, I think, because it's cheap. The computers are less expensive. Macintosh computers are really spendy. So if you're buying like 40 computers to kit out an office, you're probably going to want to buy those $300 HPs and not the $2,000 Macintoshes. But Mac OSs are increasingly popular for individuals and small businesses and things like that. Chrome OS is a budget computer that is designed to be inexpensive but leverage the power of cloud computing. So remote services that supplement its power. And Linux is a kind of a family of operating systems that are open source and free and getting to the point where I'm pretty sure pretty much anybody could use Linux these days without experiencing any discomfort. It used to be really only like advanced users. And then of course you have your two mobile OSs, and there are others again. There are others, but nobody uses them.
So
Android,
the Chromebooks are fine then, or
for this class, yes.
Okay.
Yeah, you'll be able to do everything that you need to do for this class. I understand that Stacy was having some trouble. I don't know if anybody's taking Psych, but her MindTap program is not working on the Chromebooks very well, and I'm not sure if that's a Cengage problem or if that's a Chromebook problem. It could be just their servers are overloaded, but I don't know off the top of my head. Without investigating it more. Yeah, Chrome OS is going to be just fine for this class because of the software we're going to use, and we'll get into that on Wednesday. Any questions about this concept of an operating system? There'll be a very light quiz on this next, and you'll be able to, obviously you're doing it on your own, so you'll be able to refer to these slides and the page in the text that describes this. So this is the page, and you can kind of read this. This is the same information, but it gets into it with a little bit more detail and maybe a little bit more nuance. Here, here's a picture of a hard drive. I always think that this is really interesting to look at. It's like a stack of pancakes. Each one of those is covered with tiny little magnets, and then these read heads that twitter back and forth and read it like a record player. It's just like a record player in concept. But it reads much more, much tinier data. Yeah, so this is all basically the same information, just with pictures and other stuff. So yeah, that's where we're at. I'm gonna stop the recording now. Boom.